Hello everyone and welcome back. My name is Mr. Coolvault, and in this video I'm going to be going over another problem on how to find the precision of an instrument, but in this case we're going to be looking at a thermometer. But before we get into this, please like my video, share my video, put comments in the comment sections, hit that notification bell, subscribe to my channel so that way you can be notified of any videos that I put out. Thanks for joining me, and let's get into this. So here we have two thermometers, and we want to know what the precision of each thermometer is. Okay, so the key here is there's two situations you could be in. First situation is you're not given any information about the precision of the thermometer. There's nothing written on the thermometer to indicate what the precision is. So in that case, you assume that the precision is in the very last digit, and you would read the thermometer and report the temperature like you normally would. So for example, in this thermometer here, you can see that we are between 20 and 30 degrees. Each line, if you look at the number of spaces in between 30 and 20, an easy way to figure out what the lines mean is to look at the numbers that you have here, subtract them from each other, and then divide by the number of equal spaces you have between them. So here you would subtract 20 from 30. So you have 30 minus 20. And then you would divide that by the total number of equal spaces between them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you would divide that by 10 and you get 1. So each line represents an increment of 1 degree Celsius. So here you could see that we have 20, this would be 21, 22, 23, 24, 25. And so you can see that for this thermometer, the liquid alcohol or mercury, usually these days we're alcohol thermometers. So here, the liquid of the thermometer is past the 25 mark. So it's between 25 and 26 degrees. So in this case, we are allowed, it's obviously past the 25, so we're allowed only one uncertain digit when we're measuring using our measuring instrument. So in this case, the thermometer uh, gives us 25. Everyone who looks at this would say, yeah, that's definitely 25. It's above 25, but it's at least 25. 25 is for certain. No one's going to disagree with that. So we write 25. So now it's between the lines. So in this case, we can estimate one digit. We're only allowed one estimation. We usually estimate one digit over. So we're allowed to estimate to the tenths place. And here there's some wiggle room. It depends on the person who's reading it. You could say, oh, I think it's in the middle. So it would be 0.5, right? Someone else might say, oh, it's a little bit above, maybe it's a 0.6. Someone might say, oh, it's a little bit below, so it might be a 0.4. So there's some wiggle room in that with regard to this digit here. That's why it's called the uncertain digit. We're only allowed one estimation. So remember, the uncertainty of your measurement is almost always going to be in the last digit. Okay, so this thermometer, without any other information, allows us to measure to the tenths place. So all our measurements should be recorded to the tenths place. So if we have the same thermometer over here, right here, this thermometer is all the way up to 30. It's on the line, right? So the same rules apply. Everyone looking at this would look at, oh, it's definitely, up to the 30 maybe, right? Or maybe not. Maybe it's a little bit below, maybe it's a little bit above, but we might say, okay, if it's on the line, we would write 30, right? But we can't just write 30. We would have to write a decimal place and remember, the instrument here, these are the same instrument. So in one case, you're getting a 25.5 or 25.6. Here, you're getting a 30, but the instrument allows you the precision up to the tenths place. So you have to write a decimal point. If you think it's on the line, then guess what you write? That is correct, a 0. So it's got to be 0.0, right? Because there is some uncertainty in this digit, right? Someone could look at that and say, oh, I think it's a little bit above, so it's 30.1 maybe. Or maybe I think it's a little bit below the line. I might say 29.9 or something like that, right? So you have to put the 0 there, even if you think it's on the line. Okay. So that's how you read the instrument when you're not given any information about the accuracy or precision of the instrument itself. But what about the case in which the manufacturer tells you that this instrument is only precise to a certain degree, right? So some instruments will say it's precise up to, 5%, plus or minus 5%, plus or minus 1%, plus or minus 2%, or something like that. They might say it's plus, they might actually tell you it's plus or minus 0.1 or plus or minus 0.2 or something like that. So what about in this case? Let's say that they tell you, oh, the precision of this thermometer is actually plus or minus, oops, not plus or minus, oops, but plus or minus 1. So 1 degree Celsius. So now we know that the precision of our instrument is plus or minus 1 degree Celsius. So we're no longer allowed to just assume 1 decimal over, because the instrument, the manufacturer, is actually telling us, nope, the plus or minus, the precision is in the ones digit, right? Plus or minus 1. It's not in the tenths like we did before. We assumed it was in the tenths, but now we're being told it's plus or minus 1. So how would you report your temperature under these conditions? Well, you're limited to the ones place now. You can't go to the tens place because the manufacturer is telling you that the precision is in the ones place, plus or minus 1. So this time, instead of being able to record up to the ones place here, or the tenths place, you're only allowed to record up to the ones place. So instead of 25.5, right, if you thought it was 25.4, you would round that to 25 degrees Celsius, right? If you thought it was 25.5 or 25.6, then you'd have to round up, right? So maybe you think then you'd have to say 26 degrees Celsius. So you're only allowed up to the ones place. Okay, same thing here. If you still think it's on the line, then we would have to get rid of that decimal place, and we put 30 in this case, because the ones place is where our uncertainty is. We're not allowed to go beyond the uncertainty of our instrument. And since the manufacturer or whoever told us that the precision of this instrument is in the ones place, then when we record our values, we have to record only up to the ones place, not beyond. So again, just to recap. So if you're not given any information about the instrument, you would read the instrument like you normally would, and then go 1 decimal over to get that 1 estimate, right? Just like we did here. Otherwise, if they tell you what the precision is, then you're limited by whatever they tell you it is. So if they say it's plus or minus 0.1, then you're limited to that 0.1, even though maybe you normally could read past that. So if it's plus or minus 10, right, then you're limited at the tens place and not the ones place. So I hope this is helpful. I hope this makes sense. If you enjoyed this video, if it helped you, please make sure you like that button, subscribe to my channel, hit that the notification bell, put a comment in the comment section, let me know what you think, and if you have any questions. Thanks for joining me. Have a great day.